All right, Fred, we're going to talk about matter and the different classifications or different ways that we can think about materials. All right, so matter can be divided in chemistry class into pure substances or mixtures. Mixtures or pure substances. Pure substances are examples of pure substances. What we mean in chemistry when we say pure substances is either something that's just one kind of element, all right, elemental, and remember, these are our different kind of elements here, all right, or something that is all the same compound or same molecule, same material, all right? So if I have a jar of gold atoms, right, so I have a container here, and inside I have gold. All the atoms in here are gold atoms. Then that's a pure substance, right? But it's also a pure substance if I have a container full of water, all right?
Wouldn't water be a mixture because you have hydrogen and oxygen?
That's a good question. It's a good question, but that's not our definition of a mixture. Just because we mix atoms together to form compounds, that's not what we're thinking of when we say mixture. So it's a good question, and we need to be able to recognize that a pure substance can have more than one kind of element in it. All right? Now, some examples of a pure substance, right? Little chunk of gold, all the atoms are the same, that's elemental. Something like gasoline, chemical formula is C8H18, right? That chemical there is a pure substance, but it's a compound, right? It's a compound. So, aspirin, for example, could be a pure substance, not a tablet of aspirin, but the active ingredient in aspirin, right? Salicylic acid, for example. This looks like it could be lots of different things. It is, it's lots of different atoms, but each unit in there is the same compound, the same combination. Therefore, it's a compound and it's still considered a pure substance. All right, let's talk a little bit about mixtures. Mixtures come in two types, homogeneous or heterogeneous. Do you know what homo means?
Homo is same.
And hetero is different. Very good. So when we're talking about homogeneous mixtures, we're not talking about the same things inside the mixture, because then it wouldn't be a mixture, right? We're talking about the same concentration of the different components in the mixture throughout the mixture. So, for example, if I have a mixture of water and something else like maybe sodium chloride, then if the sodium chloride and water are all both dissolved in my mixture here, my solution, then I would say that it's a homogeneous solution. Because if I looked over at this spot, I would see that the amount of sodium chloride I have is the same as over in this spot. Okay, so that would be an example of homogeneous. However, if I had a different mixture over here where I have some water and I put in a lot of sodium chloride and I actually get some undissolved sodium chloride at the bottom, then I would say that this is a heterogeneous mixture because the amount of sodium chloride here will differ than the amount compared to the amount of sodium chloride there. So homogeneity or heterogeneity, that is referring to the concentrations in different locations of the different species. Okay, very good. So, for example, milk. When you milk a cow, have you ever milked a cow?
Yeah, I did that. I did that at the state fair once.
Good job. Did you get to see what comes out of the cow?
Yeah, it's milk.
Well, did you ever get to see a full bucket of freshly milked cow milk?
I didn't do that myself, but I went to a cousin's farm and they had to milk the cows all the time and I saw the milk.
Oh, great. Did you get to taste it or feel it?
Oh, it didn't look very good. It was warm and it didn't look nice. They poured it into a glass jug and it just looked like white water on the bottom with a bunch of cream on top.
That's right. That's right. So milk comes out of the cow in a heterogeneous mixture. But we homogenize it with by shaking it really strong and using sound waves to break up the fat that is in the cream on top to spread it out homogeneously in the milk. All right, because that's the way we like to drink our milk. So milk is an example of a mixture, has lots of different things in it. And what do you think is the main component in milk?
Is it the fat?
No. What other kind of main component might there be?
Protein?
Milk contains fat and protein. Anything else?
Vitamins? Minerals?
No, the main component is just the water.
Oh, yeah. I knew that.
Yeah, that's right. So we drink water in general. So everything we drink will be containing water mostly. The only real exception is if you drink something like vodka, which is basically alcohol, okay? So other mixtures that we're aware of, salad dressing is an example of a mixture. It is not mixed very well all the time, and so we can use this as an example of a heterogeneous mixture. If you put some food coloring into some frosting initially, you can see that it doesn't mix very well, heterogeneous. This thing here, do you know what this little box is trying to represent?
No, I don't.
Well, these blue things here are atoms of nitrogen, and the red ones here are atoms of oxygen. Do you know a mixture that might contain nitrogen and oxygen?
No.
Well, air. Air is actually a combination of nitrogen and oxygen. Do you know what is the highest concentration in air, nitrogen or oxygen?
Oxygen?
Actually, it's not. Actually, it's nitrogen. Nitrogen is about 80, or air, sorry, is about 80% nitrogen and about 20% oxygen. A little bit of argon and carbon dioxide, just trace amounts though. Really, it's mostly nitrogen, okay? So it's an example of a mixture, all right? What do you think? Is air homogeneous or a heterogeneous mixture?
Well, you have it under homogeneous.
That's right. That is right. It's down here. It's under homogeneous. So that means essentially that if I breathe the air at the top of the room, it's going to have the same amount of nitrogen as oxygen as if I breathe it at the bottom of the room. Okay? So the air is pretty well homogeneous for a laboratory, for example. If you get up to the top of the mountains, way up high, then there's some significant differences. Remember how if you climb really tall mountains, you have to start wearing gas masks to provide, not gas masks, but masks that will provide oxygen for you, right? Artificial respiration systems. Okay, very good.
I climbed a big mountain once.
Really? Where at?
In India.
Oh, wow, that's amazing. Was it exciting?
It was very exciting.
Did you have to wear a gas mask?
I didn't go up that high, but there were people passing me that did.
Wow, that's awesome.
And also, I don't know if you know it or not, but I don't really breathe oxygen.
You don't?
No.
Why not?
Well, it's kind of embarrassing, but I'll tell you about it later.
Okay, all right. Sounds good. All right, so let's see if we can figure these compounds or these materials out in terms of whether they're pure substances, elemental, molecules, that sort of thing. How about we start with hot cocoa? And this means like hot chocolate that you drink. What do you think? Pure substance, element, compound, molecule?
I guess it's a compound because it's mixing different things.
Well, what kinds of things are it mixing? What do you think is the main component in hot chocolate?
The cocoa.
Actually, it's water, right?
Oh, yeah, that makes sense.
So the water is the main component. So we're looking at a mixture, aren't we? Because we know we have water and we know we have chocolate. And for that matter, if they're taking cocoa beans and grinding them up, cocoa bean is a living organism. It has so many different compounds in there. So when you grind it up, you have a lot of different compounds. So this is going to be a heterogeneous mixture or maybe a homogeneous mixture, depending on how you like your hot cocoa. How about ice? Ice.
You said water is a pure substance, so I'm going to go with pure substance.
Very good. Is it an element?
It's made of elements, so does that mean it's an element?
No. All right. If it's an element, it has to only have one kind of element. So it's pure substance, but not an element. How about a compound?
What's a compound again?
Compound is just a combination of any elements. So yeah, this is an example of a compound. All right. Any combination of elements is a compound. Now, a molecule was a little bit different than a compound. Do you remember what the definition for a molecule was?
It was a compound that only contained nonmetals.
That's right. So a molecule only contains nonmetals. Is water one of those scenarios?
Yes, because oxygen's a nonmetal and hydrogen's a nonmetal.
Very good. So what have we decided? We have a pure substance, we have a compound, and we have a molecule.
Yep.
Is it a mixture?
Is some of the ice melted?
Well, even if it was melted, would that mean in the liquid phase or the solid phase that I'm changing the kind of compound or elements it is?
Oh, I guess not.
That's right. It doesn't change it. So, pure substance, compound, and molecule. Very good. White flour.
How do you get white flour?
I don't know. What do you think?
Well, you get wheat and you must grind it up, I guess. And I don't know what they do after that.
Well, they grind it up. That's right. And from that information right there, again, wheat is a living thing. It's an organism. It's a seed, right? You're taking it and you're grinding it up. Everything in there is going to have enough to make a new organism. So you're going to have protein, DNA, fats, cells, all sorts of things in there. So this is not going to be a pure substance by any stretch of the imagination, and is not going to be elemental, not a single compound or a single molecule. The only question we have to ask ourselves is, do you think it's heterogeneous or homogeneous?
You asking me?
Yeah, what do you think?
I guess I would say white flour looks homogeneous.
Okay, probably right. And, you know, if from other people's perspective, if they got small enough, they might be able to say it's heterogeneous. But I think most people would have to agree that white flour, no matter where you look at the container of it, it's all the same. How about sodium chloride? Chemical formula NaCl, sodium chloride. Have you heard of sodium chloride before?
Yeah, I've heard of that. I think I had it in science class before.
Okay, very good. Sodium chloride.
It's also known as salt.
Yes, salt. However, in chemistry class, the term salt, really what the term salt means is any ionic compound. Now, is sodium chloride an ionic compound?
I don't think salt has metal in it.
Well, let's look at our periodic table. Can you find sodium atoms on there and chloride atoms?
Oh, there it is. Number 11 is sodium. And number 17 is chlorine. So number 11 is sodium is a metal?
That's right. Sodium is a metal.
We eat metals?
Well, ionic compounds are not metallic in nature, but they are a combination of an atom, which is a metal, and an atom, or atoms that are metals and atoms that are nonmetals. When you combine metals and nonmetals, you get salts, ionic compounds. So yeah, in a way you can think about it, we are eating metals from that perspective. So what do you think? Is sodium chloride a pure substance?
No, because it's mixing sodium and chloride.
Remember, that's not our definition of a pure substance, or a mixture, right? If all of the units all look exactly the same, then it is a pure substance. And it's also a compound, again, combining atoms together. Okay, good work, very good.